Welcome, dear learners. Technology has been growing so fast that all the areas in our day-to-day routine has been influenced by some form of technology. And that is true with the case of blockchain also. Blockchain has traversed miles and has now become a very hottest area in the technological arena. Today, in my learning session, I will be introducing to you the concept of blockchain and why it has become so peculiar these days. As the name itself says, it is a chain of blocks, and let us see what exactly it is through my presentation. As the name itself implies, blockchain is a shared ledger, a distributed ledger that facilitates the process of recording transactions and the transactional assets in a network, like money, like certificates, like tangible assets like property, house, vehicle, and also maybe intangible assets like digital currency, the intellectual property, etc. All comes under the context of blockchain. So basically, the blockchain stores data that is irreversible, immutable, and it moves in a distributed environment. Let us see the concept of blockchain. A blockchain is actually a decentralized distributed ledger, as I was also already explaining. What do you mean by distributed ledger? A distributed ledger means a ledger shared among the users. And that is true with the concept of blockchain as well. In the blockchain, each block will consist of timestamp, the time at which transaction has been recorded, and a link to a previous block. Therefore, by design and purpose, the blockchains are irreversible and immutable. That is, it is inherently resistant to modification of the data. So that is the basic advantage of blockchain, and that is why blockchain has become one of the most hottest subjects in the technological arena these days. When you go through the literature, you will find that blockchain has been influenced in the sectors of education, banking, government, finance, etc. So functionally, a blockchain is an open distributed ledger that consists of transactions between two parties efficiently and in a very verifiable and permanent way. The fundamental concept of blockchain consists of cryptographic algorithms. You know that there are various kinds of cryptographic algorithms available, and most of these cryptographic algorithms take a major role in the technology of blockchain. This system, which was developed during 1991 and later on by Satoshi Nakamoto from Japan through his white paper on Bitcoin, the basic focus is that the trust that is entrusted with organizations with respect to currencies, with respect to trusted records, is transferred to the blockchain and the cryptographic algorithm that it uses. So basically, the trust is transferred from an organization and the trust is transferred to the blockchain itself, which is secured through some kind of an cryptographic algorithms. All the transactions in the blockchain are validated through some mechanisms, and it is because of these validations that there exists something called as trust. Let us see a typical example of the performance of blockchain. I have a figure here where the figure has two parts. In part A, let us see that there are party A's record and party B's records. and the trust is maintained by the records stored at banks and the records audited by the auditors, which are generally intermediary third party components. Now let us move to the context of a transaction that blockchain is implemented. Here we have two parties, party A and party B, and all the credentials of party A and party B are also replicated with other parties, digitally signed and encrypted, and therefore all the parties which has the same data of party A and party B validates the transaction. So in this case, we are eliminating the third parties, the auditors and the banks, and that is why the cost of transactions happening through blockchain is very minimal. Some of the advantages of blockchain include a decentralized characteristics, a distributed characteristics, secure and faster way of transaction, something which is transparent and immutable, which I have already mentioned. Again, something called as a trusty chain and indestructible technology. Now let us see what is the logic of the blockchain. The blockchain is built on a peer-to-peer network. What do you mean by a peer-to-peer network? In conventional computational technology, most transactions happen in a client-server network, where there are a set of clients and there is a server validating all transactions happening through the client. In this blockchain technology, we are eliminating the concept of a client server technology and we are making use of a P2P, that is peer-to-peer technology, where all the peers engaged in the blockchain validates the transaction and ensures the trust. So that is what we have mentioned, the idea of a peer-to-peer networks, which generally provides a universal data set that every actor can trust, even though they might not know who is on the other side, or they might even not trust the people on the other side. Therefore, it provides a shared and trusted ledger of transactions where immutable and encrypted copies of information are stored on every node in a network. By default, how then would be the data be stored? Generally, in a client-server environment, the data is stored in a database. And we know that in a computational terminology, database becomes one of the most prominent component in any information system. Fortunately, in the case of blockchain, we have a new technology called as a backlinked record of blocks of transactions, wherein we are not going to use something called as database. We are going to store the data as something called as hash files. So generally this hash file data is saved as a file or maybe in a plain database. But there are very rare chance that we use a database. We store it as a plain file. And each block of the blockchain is recognized by a hash generally created utilizing the SHA. The SHA stands for Secure Hash Algorithms. Now, SHA 256 is a specific secure hash algorithm, a cryptographic hash algorithm, and that is the main header for each block. Let us see the data structure visual representation. These are some of the blocks of blockchains, or these are the visual representation of blockchains, where each block will consist of a transaction data consisting of all those transactions related to their assets. And each transaction data will also, each block will also consist of a link to a previous hash. Now here we have a previous hash, which is previous hash, where the previous hash is linked back to another block of the transaction, previous transaction, and that block also consists of another previous hash. That hash is again linked to the previous transaction and so on. Therefore, some of the components of this data structure include the index, which symbolizes the location, the hash, which is nothing but the hash function that facilitates the classification of data. We also have something called as previous hash, which will link towards the previous block of the blockchain. We have a timestamp. A timestamp is nothing but saving the time of the current transaction. And again, a new principle called as Merkle tree. What is this Merkle tree? This Merkle tree is otherwise called as a binary tree, which we all have learned in our previous computing classes. This binary hash tree is nothing but a data structure generally utilized for compiling and validating uprightness of a large set of data. So we have index, we have the hash function, we have the previous hash function, we have a timestamp, and we have a Merkle tree. So as explained, the blockchain has its own unique data structure or data storage structure. And the approach of data storage in a blockchain is entirely different. As I was explaining a little earlier, we are not going to use a client-server data structure, but rather we are going to use something called as a peer-to-peer model. What is this peer-to-peer model? The peer-to-peer model data distribution approach gives the reason behind unfettered nature of blockchain, and thus there is no central authority in blockchain. So the trust happens because of all the parties playing in the blockchain agrees the transaction. Now this is the conventional server-based concept where all the clients respond to a server, whereas in a P2P network we have peer-to-peer agreement happening, and thus there is no dependency on something called as a server. Now one major problem that arises in the clients in the blockchain is that when we think about client-server model, the data is generally stored in database after verification of a central authority. But in the case of a P2P network, there is no central authority. Then the question arises, how does the authenticity of data is assured? Our simple answer to this question is nothing but the validation process and consensus mechanism of blockchain network. How do you validate this blockchain? The validation is a very important aspect of the entire blockchain terminology. In a blockchain, the assets and its transactions are stored as connected blocks in the blockchain, and only the validated transactions are added to a blockchain. That is, validations done by all the parties engaged in the transaction, or all the parties engaged in a blockchain accept a transaction, then only it become a validated transaction. So in a validated transaction, there will be a hash value generated, a hash value calculated using some cryptographic algorithms like the secure hash algorithm 256, one kind of a specific algorithm, cryptographic algorithm, which is irreversible and immutable. Therefore, all the blocks that are added to a blockchain becomes part of a blockchain only after the validation process. Now, when you look into this validation in detail, when a transaction takes place in the blockchain, sometimes there is only one transaction, sometimes there are several transactions per block, and it depends on the block size and the nature of the network. Therefore, when a transaction is added to the block, it must undergo some form of validation before it is being added to a blockchain. That is, we will not be having hash values, same hash value for two blocks. For every separate blocks, we will be having separate hash values. The second major property for any blockchain terminology is that The hash values should be irreversible, which have already been explained. Irreversible. That is, you cannot go back to the original transaction through the hash value. Some of the applications of blockchain include the smart contracts, the cloud storage technology, the personal identity solutions, the networking and Internet of Things IoT, cyber security, crowdfunding, insurance, supply chain and logistics. So, to summarize, the blockchain is going to be the technology for the next future. And with the growth of this blockchain, it is posing a large amount of threat to present applications in terms of technological advancement. And therefore, we can expect a blockchain technology implemented either in one way or the other in some of the applications that we are going to use in our day-to-day life.